So any question regarding that? You good? Okay. So then you need to find the voltages. I think this is R1 and V1 and V4 using voltage divider rule and insert the values in table 9.7. Okay. So this is for the first circuit. For second circuit, this is a little bit different. You need to find voltage V4 using Ohm's law and compare it with simulated results and insert the values. So you need to, it's up to you how you do that. These two resistors are in series and they are in parallel with this resistor, and then the equivalent, this equivalent will be in series with this resistor, right? So you will find, either you can find equivalent resistance and then compare, calculate it. It's up to you. You have multiple techniques now that you can find, calculate, that you can find voltage V4. Similarly, you can find simulated current IS and calculate the total input resistance from Ohm's law. So once you know IS and E, you can find R equivalent simulated will be E over IS. Okay, and similarly, what in this exercise, what you need to answer, you need to calculate RT, which is your equivalent resistance, and compare it with your simulated value. Equivalent resistance you should calculate with your parallel and series combinations. Then what you need to answer that if your R2 is greater than R3, if this R2 is greater than this R3, so means it is 1 mega ohm, which means that you are squeezing this path. You are making very, very hard for the current to flow in this path. So what changes will happen in IS and V4? What do you think will happen? You can check that in your simulation. What changes or what changes will happen in the circuit if R3 is short? If this circuit is short, if this element is short, what do you think will happen? And similarly, if your R2 is short, what do you think that how current and voltages will change in the circuit? Okay, am I clear about that?
Yeah.
Okay, so you all got your kits?
Yep.
Yeah.
Okay.
I don't.
Smile, did this ship to you?
Yeah, they sent it, but I don't know when it's gonna get here, so.
Do you have the tracking information?
No, but my other friend that lived um in another state, they shipped it to her and like she got it, so.
Okay, so it's for you, it's in another country?
Yeah, so I don't know when it's gonna get here. So.
So
Um,
what did they say? When did they ship to you?
like the
How
chair,
long?
the chair said that they shipped it last week, so I don't know when
Okay.
it's gonna get here. The worst case is just me going to an electric shop and buying the components on my own.
Yeah. These components are not expensive, but um, I mean, I'm not sure how much they cost where you live. So, but here they are not very much expensive. But I'm not saying that you should just buy all the things. Maybe it arrived by next week or so, right? So maybe if you really want to do this, just buy the equipment that you are needing in this lab, maybe, right? But again, if you want to wait, it's fine. You can submit your lab report later, you know?
Okay, thank you.
Okay. So what we need today will be, I'm showing you 1 minute. I just take my things out. Okay, so you have seen that we have these resistors, right? So I will be using 1K resistor. Okay, so this 1K resistor, and I already put my batteries in the holder. So these two batteries in the holder. Okay, and I will need a multimeter. So this multimeter, and this is a small breadboard. Okay, and you have these wires, right? Do you have these wires?
Yeah, yeah, we do.
Okay, so, and then you have this plier too.
Hmm.
Yes. So what you need to do, you can just take off this lock and this should be open. Okay. And I know most of you know how to use it, but I'm just showing that we may need small wires, which we will put in the breadboard. So you may be using this, like just cut it if you want to cut the small piece, and then we may need to do the both of the ends like this. We need to, so make it like that. I want to expose the conductor part of this like this, and from both sides. Okay, so I cut a very little piece, but I think we may need little bit bigger ones like this. Okay. And let me open lab number 3. I actually updated it too. Let me open it. I You just don't immediately need all these things. I'm just showing you, and first we will go through the introduction, then we will um, do that. Okay. Okay. So this is lab number 3, and these are the objectives. So we will try to know all the equipment that we will use in this lab, most of the equipments, I think. And I prefer that you build the circuit, show me, and then log off. Okay? Because in the last lab, it happens to some students that they actually, I don't know what they have done, but their batteries were like little bit hot or stuff like that. So I just wanted to check that it may, I don't want that this may happen to you. Okay, so I want you to build the circuit and show it to me. Okay, and then we may need power supply. We don't have, we have batteries. We will need DMM, which is digital multimeter, and breadboard, and of course the resistors and stuff. So what is digital multimeter? So this is the digital multimeter, and it can measure voltage, current, and resistance, all three of the things. And the first step in this DMM is to select desired measurement function. Let's say if you have a look at it, it has multiple functions. It has DCV, which is DC voltage, DCA, which is DC current, amperes, and ohm sign, which is resistance measurement. Okay, so if you want to measure, let's say, ampere, you will move the knob towards the ampere, and the knobs, the dot of the knob tells you exactly which position it is. So then test lead must be connected to the front panel jack. So these are the test lead. Red stands for higher voltage, and black stands for ground. So black I will connect to the ground, which is this COM thing, and red I will connect to the volt. Okay, so these two leads I have connected. Then when measuring current, you must use the bottom two jacks on the right side, and so it's different. And for everything else, you use the top two jack on the right. So for this, it may be the right side, but here it is like this. So this knob is for measurement of higher currents, like the up to 5 amperes of that. But these knobs, this knob can measure voltage up to 250 volts and the currents up to 200 milliamps. So if there is a circuit where your current is greater than 200 milliamps, then you can shift to there. Otherwise, you will use these two holes. Okay, the test lead must be connected to your circuit differently for different kind of measurement. So that we will see. Can you access the document?
Yeah.
Yeah.
Okay. So voltmeter, if you see this voltmeter is actually measures the voltage. So this is your voltmeter, okay? This is your ammeter and this is your ohm meter. So to measure the voltage, you place your leads in parallel with the device under test, okay? Like, I'll show you maybe. So if this is your resistor, and to put it in the breadboard, I will do this like that. And oh, maybe when I'll show you breadboard, I'll show you too. However, you just keep in mind that these leads should be in parallel when you are measuring the voltage. When you are measuring the current, you need to break the circuit, put your ammeter inside it, and then you can measure your current. For current and voltage, you need to take care of your lead colors. Like here, the red color is connected to the higher voltage and black color is connected to the lower voltage. Similarly for ammeter, like the current. But for ohm meter, you don't need to worry about signs. So resistors, if you use the other side or swap the leads, it's okay. You will not see the difference. So we will learn how we will measure the current. If you connect test leads to the current measurement jack and then connect to the other ends directly to a higher current source, such as. So while measuring current, we need to be little careful because we don't want that a lot of current may pass through the equipment, like the true DMM. So always before measuring current and after measuring current, you just need to turn it off. And similarly, there are some, safety precautions you should take that may not cause damage to you or the circuit, okay? Okay, resistance measurement is made by injecting a precise current and measuring the resultant voltage, of course. So you generally can't measure the resistance of something that is connected to any other source because its resistance is dependent on the current and voltage. For resistance measurement, you can interchange red and black test leads, okay? So DMM has auto ranging, like you can select, let's say, if my current is, like right now it's in the current area. So if my current is less than 20 milliamps, I will be adjusting it to 20 milliamps. Right now it is at 20 milliamps. And it will automatically adjust itself to give me the right reading, okay? So you just select the maximum point that you think it lies within, and it will automatically select its range. Okay, now there are the components. So we have resistors. They look like that. These are all kind of resistors. There are different power ratings, as we know. So these are the resistors. We have some of them here as well in our kit. So most of them are resistors, and we will learn about their color code later. Then there is capacitor. Capacitors are, we have some capacitors in our kit, I think 100 microfarad capacitors. And when we learn about them, I will show it to you. So these are some circular components. These are capacitors in the kit. Excuse me. So there are some potentiometer. Potentiometers are the variable resistors. They have three lags. One is the changing lag, and they are also in all kinds of shape, and you can change them by turning their knobs. Then there are inductors. They look like that, and there are some inductors with the turns, like we can see their turns, and there are inductors in which we cannot see the turn. Then there is a 9-volt battery connector that right have. Just a minute. Can you listen me? Can you listen to me?
Yep.
Yeah.
Okay. So then there is this holder. I just want to tell you a very important thing about this holder. Okay. So this particular holder is actually connected in series, which means that you cannot get 1.5 volts out of it. You can only get 3 volts out of it because they both are connected in series. They will not work if you just want to get 1.5 volts. If you want to get 1.5 volts, there are separate holders that you can get and use them. But the person who prepares the kit got them. So it's okay. We will use them in series, but we should be beware. Like you cannot just take one cell or the battery out and use it still. Okay, so it will work only when you will have both of the batteries in it. Okay, here they are talking about 1.5 volt battery connector, which is this plastic case, but we don't have that. We have this 3 volts one. Okay, now this thing of breadboard. Okay, let me, make my other webcam ready. 1 minute. Okay, so can you see this?
Yeah.
Yes.
Okay, so this is the breadboard. Okay, so in this breadboard, you can see from the document as well that there are 3 areas that we should look into. So this is the power rail thing. Okay, this is the circuit area where you will build your circuit, and this is again the power rail. So in power rail, the red line shows the positive thing, so they are all connected together. Okay, and similarly blue line shows the ground, and they are all connected together. You can see in the document that the red and blue lines are all connected together. Similarly, in the circuit area, if you see in the document, green line connected vertical holes. Okay, so they are connected in vertical but not in horizontal. Got it? Please open the document with I'm in front of you too, so it will be easy to understand. Got it?
Yeah.
Similarly, in bottom part, you see the power rails, okay? So this power rail is not connected to this power rail, but they are similarly, they are also connected to each other. Okay, so if you feel confused about your breadboard, you open up this document and see this picture, you will be clear about that. Okay, so another thing I want to tell was that, where's my resistor gone? Okay, another thing I want to tell you about that is that if you want to connect your resistance in series and parallel, how you will do that. Okay, so if you see this breadboard, or in the document, if you see, I told you that they are connected in vertical lines, right? And in series resistor, you know that one of the legs should be connected to each other. So that's why, as these vertical lines are connected, so you can put one leg in one hole and the other leg in other hole, and they will be connected, and the other two legs will be on the other holes, so they will be you can say that they are connected to each other. In figure 8 I'm talking about. Okay, am I clear about that?
Yeah.
Okay, then if you move further here in figure 9, you can see that uh, they are connected in parallel, and in parallel, you know that both legs should be at the common point, and you know this is the common point, so that's why your both legs will be on the common point, and that will be the connection in parallel. But right now we will not use two resistors, we will just use one resistor, and we will do first of all the continuity check. For continuity check, if I check my these holes to each other, like if they are connected to connected or not, I will see very small resistance in my leads. And if I check these two holes, I will not see any resistance because it's too much and they are not connected. Similarly here, if I just check here, I will see resistance changing, but here I will not see anything because it is not connected to each other. So let's try that. So what you need to do, turn on your turn on your DMM, okay? I turned it on, right? And I put it on the resistor value. So it's very low resistance, so just put at the minimum value. That is 200 ohms, okay? And then you can check the continuity. So I check continuity by taking two small wires. These two small wires I take, and then I put them in the holes. Okay, let me show you. So I will put the wires. Sometimes it's hard to put them in the holes. So I put two wires in the same vertical line. Okay. So why I'm putting these wires, because they will help me to connect the lead. And then I will use these two leads by turning it at ohm meter and check their continuity. So you can see that your resistance is changing on your DMM, and it's very small value you can see. So I am putting my leads on the wires. Right? Can you see that? you can see the resistance that is changing on this multimeter. If I just put it up here. Like that. Let me show something like that. Can you see multimeter screen? Can you see it changing? It's so dark for me.
Yeah, a little bit. It's kind of dark.
So it's changing, which shows that it's connected. Okay. Like that. Okay. You can see that it's changing. Okay. Now if I move my wire from here to any other hole which are not connected like that, okay, so I will check them. You see that it's not changing at all, which is that they are open circuit. They are not connected to each other. Okay. Got it? Similarly for power rails, if I connect my power rails to such that, like this, like the power line, or even if I'm not connected, so if this, as they are all connected together, so it should be changing its values, okay? You can see that, right? Because the power rails are connected to each other. And if you connect it to the other negative part, which are not connected to each other right now, like this, then you will not see any change. So this is a continuity check we will be doing, and they are, if I connect the both, you can see the change too, because they are connected to each other. So that's how you can see your continuity check, okay?
Are both circuit areas connected? Like if you put them on the same line?
Can you see your figure number 7? Ismail?
Yeah.
What is your question?
Like the circuit areas, like the two columns, the
No,
two,
no. So
they're
you are
not.
talking about this is connected to this, right?
Wait 1 second. Which one?
What you are saying to me, if this column is connected to this, that's what your question is?
Like the one that you're touching right now and the one above, those two.
This too?
Yeah.
No, they are not, because you can see in your circuit area that they are not connected to each other, right?
Oh, okay.
Yeah, okay. Similarly for power rails, they are not connected to each other. Okay, so you can do the continuity check, and next you will make the circuit, okay? I think I have changed the voltages because that you cannot see 1.5 volt. Let me check that. So in your, the document shows 3 volts or 1.5 volts? in your document,
It says 3 volts.
yeah, I have the wrong one. Just a minute, let me open it. Okay, let me quickly open it. So do you have any question till now, or you're clear about this breadboard, EMM, and other things? Okay. Now let me share my screen. Okay. So now we will be doing here. Okay. So actually we know this resistance. We know that this is 1K. Okay. This resistance is 1K. We already know that. But I will actually think for this circuit that we don't know that, and we need to find out this resistor. Okay. So what I will do, I will move its legs. This is one resistor. I will move its legs like that so that it can go in the breadboard easily. And I will put it in the breadboard. So if I put these two legs in the breadboard in the vertical direction, the legs will be shorted. I will not do that. Okay. I will put it like this. Can you see that?
Yeah.
Okay. So I will put it like that. And then I have to connect 3 volts battery. Okay. So my both cells are inside. I will not connect it yet. Okay. I'll just put it like that and I'll put it here. Okay. The other thing I will do is my red wire is showing that this is a positive voltage. And my blue wire is showing that this is a negative voltage like that. Okay. Now I will put my one, I should connect my positive to the one leg of the resistor like that. Okay. Is it clear? Is it clear?
Wait, is that blue and red wire supposed to be in the lab kit?
No, you can have black and orange, it's fine. Or red and orange. No, red and black. You don't
All the
have
Oh,
any?
okay.
It's all the same though, right? It's kind of just for labeling.
Yes, it's just the wires are same. It's just that we use red as the positive sign and blue or black as the ground.
Gotcha. Thank you.
So am I clear about that? Can anybody show their circuit if they are doing it with me? Am I clear? Smile, am I clear?
Yeah.
Tyler. Yes, you can show. You can just show the circuit. Yes, that's fine. Thank you very much. Okay. So you can just do that with your resistor. Now, if I just show you by switching my camera, okay. So this is the thing I have. Now I will connect the battery, okay? This one. And to connect the battery, I will do positive in the positive side lead. Don't connect it yet, just see me and then you can do it. Like that. Right? And you should be careful, your battery should not be heated if your circuit is fine, okay? So if you think that it's heating up, you just take it off immediately, okay? Don't harm yourself, but just check what is the wrong or what is the mistake we have done, okay? So your positive and negative leads should not be connected to each other, one thing. The other thing is your positive and negative leads should not be on the same slot so that they can be shorted out. So one is in the power rail, like the positive one is in the power rail and negative one is the ground one, okay? So that's how I made the figure number 11. And now I will check in front of you the voltage across it. So to check the voltage across it, I will move it towards the voltage thing. So I will do it in 20 volts because this is 3 volts. So I will move it to 20 like this. I will move it to 20 where the dot is pointing out at 20 DC volts. And then I will try to check the voltage. One thing you should notice, these are my leads and this is my circuit, okay? One thing you should notice, okay, is that if I am measuring the voltage, I should be putting it in parallel with the component, okay? So this is my resistor and I should be putting it in the opposite direction. Positive should be going towards the positive side and negative should be going to the negative side. So I'm measuring, so you take the maximum value because my hand is moving, that's it's moving. So this 2.95 is my maximum value I'm getting, okay? So 2.95 is the value that I'm getting across the resistor. Is it okay? Can you see my multimeter in the reverse direction or in the original direction?
No,
It's
we can
forward.
see it properly.
It's for like it's in the reverse direction you are seeing the values?
No, it's all regular. It's not mirrored.
Okay, that's fine then. So yeah. .98 even I am going. So the maximum value I will record it in the table, okay? So make the table, I think it didn't mention the table, so you make the table yourself across which you may measure, you say that this is the voltage you have recorded, 2.98 in my case, and then you will put the current, okay. So for the voltage, I just put my leads across the legs and that is in the parallel of the equipment, okay, that's fine, or the resistor. But now for current, I need to break the circuit and put the what you should say ammeter in series with it, okay? So what I will do, okay, so once you're done with your experiment, take off the cells and they are not heated up, they are just fine, okay? If you are not playing dangerous games with that, or if you are not mistaken somehow, I feel that there should be fine because I received the same kit as you guys. So I'm not sure why in the previous they were heating it up. Okay. So now this is the thing I have, okay? Till now we are fine.
Oh, which resistor was that again?
We don't know a resistor yet. I just picked out 1K resistor. Yeah, but I'm trying to, so this is 1K resistor, but I'm trying to find resistor using Ohm laws as well, okay?
Okay.
So, but this is 1K. So this is the circuit we were having, okay? Now I will break the circuit and I need to break it from the positive side and put the ammeter in series with it, okay? To break the circuit, I will take this wire out and put it anywhere else, but not at the resistor leg so that it will break the circuit, like this. Got it? Okay, now I will put 2 small wires so that I can access lead easily, okay? And you need to be careful about that resist, like that your wires should not be touching any other wire. Okay, so this is how it looks. So what I did, I actually put one of the wire in the same vertical line where I am planning or where I break the circuit, okay, like this. And the other wire goes in this resistor. So if I connect my ammeter here, now I should be doing positive, the red lead. It's up to you, but I'm just trying to maintain the, signs. So if I connect my ammeter here, so it will make one circuit. Having ammeter in the, or DMM, if we use it as a measuring current, it's called ammeter. That's why I'm saying it's an ammeter. So if I put my DMM in between these two or connect my leads here, then my circuit will be complete, okay?
My battery is getting like really hot, but it's not even like plugged into anything.
Okay, can you show me? Stop doing what you are doing. Can you show me what it's?
Okay. Yeah, it's just, here, let me turn on my video. Hold on.
So what,
Okay.
you just, yes?
It's literally just sitting here and it's like hot. Like it's not even plugged in. And this is like melting. Like I don't even think I could take the batteries out right now. Like
Why
right
it's
here is
happening
like
to some of them, I don't know. Maybe this holder is faulty, right?
I think so, because it's really just the holder that's, the batteries are warm, but like the holder's like literally melting. And I like didn't even plug it in. Like I think I plugged it in for like 1 second and took it out.
It is happening to anyone else? So just leave it. If it is too much hot, you just leave it. I just want to show you. So did you plug this like that, like we normally do in the cells?
Yes. Hold on, let me take it out and just.
No, if you cannot, it's fine. But I'm just making sure why it's happening to some. I think these battery holders are maybe faulty or something.
It's only like really like the one, like right here. Like I don't know if you can see it, but only right here is like really hot, and that's the part that's melting. Like right here.
Maybe I think some of you are getting the shorted ones or not. I don't know what's happening. Anybody else has the hot batteries?
Mine is okay.
Okay. Okay.
Should I take it out of it, you think?
Yes, you should.
Okay, I'll do that.
And Michelle, I will actually talk to Chair about this problem. I think
Okay.
more than one person is having this problem. Yeah, in the last lab, some people are having this problem. So I will talk to them, and I don't know what they can do about that. Okay, but they will.
Okay.
We will let them know that what's happening. Okay.
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 Thank you.
Anybody else has this problem? Gina, Sarah, Lam, Cindy.
My batteries are fine.
Okay, Tyler's batteries are fine. Jessica, Angelo. Anybody has this problem?
I haven't been trying, so I don't know.
Okay, but I just don't want you guys to, take a risk. So just if you think that it's getting hard and very hard, you just don't do it. Okay, we can see what we can do about that. Okay, so this is the thing what I was showing. Is it clear what I'm showing? How you break the circuit?
Is it just an extra wire in the same vertical direction as the resistor, and then the extra wire, or just the red is
Yes.
out?
Yes. Just to, when we will connect our DMM here, it will complete the circuit, right?
Yeah.
Because it's positive, current will go like that here and then come here. So this is actually breaking here, but I will connect my ammeter here. Okay, so I'll not connect the batteries again. Okay, this is the battery, and I'll put there. Okay, so they are connected now. And now I will do this. So the red wire you have seen, I will put my positive side there, and then, but no, sorry, I should turn this off first, okay? And then turn it on. It was on, and then I will move it to the ampere section, and let's say it's at 20 amp, like this. Now it's at 20 amp, and I just turned it off and then on, and then check the measurements of the current. Now what I was saying is that I should be making sure that my positive lead goes where the positive current is coming, and negative lead goes where the negative current is coming. Okay, so you can see 2.99, right? 2.99, 2.98, right?
Yeah.
So that's how much current is flowing through that. Okay.
What unit is it set to right now? Is it
It's
like
20
milliamp?
amp, which means that it's giving me milliamps. So it's 2.9 milliamps. Okay.
Gotcha.
So if you do R is equals to V is equals to IR. So R is equals to V by I. So which means, I'll take the batteries off. So which means that it is giving me what? It is giving me 1K resistor, right? Almost. So it's 2.98 and 2.99 milliamps. Okay.
Would 3.2 be close enough, or do you think the breadboard is set up wrong if it's at 3.2?
No, it's okay. Why you are getting higher voltages and current, we will talk about that as well. But whatever you are seeing, even if you are seeing 3.22, 3.25, it's okay, okay? Some can see higher too. Why they are seeing, we will know it later, okay? So you write down your values, it's okay.
Is that the tolerance that we learned about in the last lab?
Yes, it's about tolerance. Like for some people, so if my resistor is 1K and its tolerance is 5%, it means that it can change its value higher or lower by 5%. So if it is changing its lower value towards the lower side, then it allows more current to flow. But if it is changing its value towards the higher side, it allows more voltage to show up. Okay? Make sense?
My battery started doing the thing where it gets hot also.
Did you put it in the breadboard for a long time?
No, just when I was just checking the value.
Can you show me? So, Gina, did you put positive in the positive side and negative in the negative? Like here, like here? I should not do that. So positive in the positive part. Can you show your breadboard? It looks like they both are in the same thing, no? Can see? They both are in the different line for me. You are mute.
You know you're muted.
Sorry, mine aren't in the same line. They were.
That's why. That's why they are shorted up.
Okay.
You
Because
know?
it's just like she was saying, it's just the one side what gets hot. And like even when I changed it on the other line, it like starts smoking.
Yeah, because it's already shorted out. So see, when I want to show you, it's really important to see. These two lines are separate, right? But these all lines are connected, right? So even if you are putting your wire here and here, they are all shorted out. Okay? So I'm not sure who was showing me before. I don't remember. Gianna?
It was me. It was Michelle.
Okay, sorry, Michelle.
But I'm still on like the first part of it, and I still have
you did not plug it in, right?
No, it's not plugged in. But I just want to show you what I had before. So
yeah, it's okay.
Tell me if it was.
But yeah.
This is what I had before.
Yeah, it's fine. But yes, that's fine.
It still like was like heating. I put the black wire, like the negative side right like here, and then the positive side over here.
Yeah, that's
and it
fine.
was still like getting hot.
Maybe your holder is not, is faulty. But for Gina, I don't know whether they were, did you put your batteries in, where they were hot?
Not really. The more I used it, though, it seems like I just the first time that I plugged it in, it was fine.
Yeah, it seems like the same time they are so near. I know you can confuse it. So they are so near to each other. You just put it you just put it in one line, they are shorted out. Okay.
Thank you.
I know they made it very tiny holes. Okay, so you see what my point was? So what I was showing you is that R is V by I. So if I'm seeing 2.98, 2.95 maybe, I can get approximately equal to current. It's very hard to do this remote lab, I just so worried about that. You guys may not blow yourself. Oh my God. Okay. So is this clear? I actually put some pictures at the end too. If you see here, can you see at the bottom figure 15 and figure 16?
Yeah.
So figure 15 is the voltage measurement when I have connected two batteries together. Okay. So let me go through this with you and then we will talk about. So this is the resistor. Can you see my mouse?
Yeah.
Yes.
Okay. So this is the resistor, right? And this resistor is in the same vertical line, the power line is going here. And it's not showing up, but it's up the way, like here. And then I have connected my battery here. Why I have connected 2 batteries, I'll show you. So after this procedure 2, what I am trying to do, I am connected 2 batteries in a series and try to see the resistor again. Okay, resistance again. So you can see when you connect 2 batteries in series, this 3-volt battery in my case, the negative side should be connected to the positive of 9 volts. You should be very, very, very careful about that, okay? And then negative line should go to the resistor. That's exactly what I'm doing here. So if you see here, my positive side is connected to the battery and my negative is connected to here, okay? So my leg, resistor leg, is not connected to this one, red, okay? It's just the open negative one that I have connected. Then this negative is, I took another wire and I connected to this positive rail because negative should be connected to this positive rail. And then I have connected my positive battery, positive line of the battery, 9 volts battery here, and negative should be connected to the other leg of the resistor. That's why negative I took and connected it to the here. Okay?
When in doubt, we can just follow the pictures on the lab, right?
What?
When in doubt, we can just like look at these pictures and set it up the exact same way.
Yes. But I did not take the picture for the 1 battery one, but I think it's clear from here. Or should I take that one too? Just a minute. Maybe I should take another picture with the voltage measurement for 1 battery. Yes, you can do for that just looking at the picture. When I was first drawing this circuit, I mean 2-3 days ago, I did also the same. I was seeing some, I was, smelling some smoke or something like that. Then I figured out, then when I was connecting the circuit, by mistake, I just did one thing short to another. So it happens, but we need to be really, really careful about that, okay?
When I connect my voltage source to the breadboard, I don't get a reading on the DMM.
1 minute, I can see you. 1 minute, I can just take this picture. I cannot. Okay, yes, show me. So what you are doing? Okay, that's fine. Now what you are saying? You are muted, Tyler.
When I connect the battery, so the positive wire to the positive side and the negative to the ground side, and then I have my DMM set to this.
Yes, but can you show me your battery? Got it. Okay. Now, yes.
So then I turn the DMM on and put the positive, and I just get a output reading of 0.
You connect where your DMM? Can you move a little bit your camera down?
Let me see.
Yes. Now it's clear. Yes.
So I put this positive on this side.
On the legs of this is on the legs of resistor?
Yeah.
You're not seeing anything?
No.
Okay, just a minute. Let me check. Is it at the voltage or at the current? Can you check your
That's
multimeter?
the 20 DC volts.
Yes, okay. Okay, so then you are checking it at the, move your leads a little bit up on the resistor. It's not changing at all, the mm.
No, I still get 0. And like all the wires are pretty like in there pretty like good.
Okay, one thing you should do. 1 minute. Take it off. Leads, take it off.
Okay.
Okay, see this thing. Put your wire, this positive wire here in the positive sign, and negative wire, sorry, positive wire here and negative wire here, like that. So the small wire, the positive in this positive side, and the black wire in this negative side, okay?
And then get like 2 extra wires.
Yes, just small wires. And then check your voltage here by putting the battery in.
Can you show me that one more time?
Yes, 1 minute. Let me put my, yes. Look at this.
Okay, gotcha. And then just connect the battery like the same?
Yes, the positive and the positive and negative. Now connect your DMM leads here, where you have taken the wires out.
Okay, I'm getting a reading now.
So you are getting 3 point something volts?
Yeah, I mean, it keeps changing, but yeah, it goes like up to 3 pretty much.
So it means that your battery is fine, okay? Your
Okay.
batteries are fine. There is something that is not connected in your circuit.
Okay.
Got it?
Yeah, that helps. Thanks.
Okay. So what we were doing, we were connected 2 batteries together, okay? So, what I was trying to see, so I will connect the circuit exactly as figure 16, okay? But you just connect wires first and don't connect batteries at all, okay? Then I will see one by one everyone's circuit like this, and then we will connect batteries together, okay? Got it? Okay. Okay. Can you hear me?
Yes, we can hear you.
Okay. Okay, let me do it then. Don't connect batteries, just connect wires, okay? Okay. Those who are not doing it right now, they can just mention that they are not doing it right now. But why I want you to do it, because I don't want that you guys, you know, encounter any problem afterwards.
Is there an easy way to strip the wires?
I'm also bad about that. Okay, let me check.
Like the whole time it took me like a good 5 minutes to figure out how to do one wire.
So, okay. So if you just try to fix it in the right hole, you know, you can just quickly, you are asking about cut it or taking this end out? What is the problem?
Yeah,
This one?
out.
This one?
If you clamp the smallest hole down on it, then it like and just like keep going around it, and then you can just use your nails to like pull out the rubber around the wire.
How do you do it for the black one? 'Cause that one's thicker.
Okay.
I guess you could just go up like to the second smallest one.
Okay.
But I still just use the smallest one.
Yeah, black one is.
Still use the smallest one. It doesn't cut the wire.
Yeah, I think I go in 2, number where there is number 2, then it may be easy for you. Let's see. Yeah, black one is thicker. See? So I did it using number 2 mm, 2 mm. It's a little bit thicker. And then I cut it. It's like if you're angry, you should start doing that. It really helps. Okay. So that's how I did. I don't know why they made it so thick, right? I don't know. Okay. So let me connect it.
Are we doing figure 16 right now?
Yes. So that's how I'm connecting it. Yes, I think I'm good. So this is positive. Okay. Yes, this is positive, and then I will be, no, I'm not right. No, I'm not right. This should be this. And this should go here. Okay. So this is the positive side of the one of the battery, okay, which is connected to the resistor. And this battery side is in series, the negative side of this battery is in series with the positive side of other. So the negative of this going here in the positive terminal, right? Yes. And this negative is coming out to go to the resistor leg. You can just connect figure 16, it's okay. Okay. Now I will connect my battery. And I have also connected this thing on the 9 volts battery. So it's provided in your kit.
My 9-volt battery is like heating up and it's not like connected to anything.
Take it out. You did not connect it or you did not short it, anything?
No, I didn't connect it to anything.
Who is this talking?
Gianna.
Gianna, can you show me?
Well, I just took it out, but it was just like heating up. I just took it out though.
Okay, no, did you connect this thing and then it started heating up?
Yeah.
And is this broken or melted?
No, not yet. It
Okay.
like just started.
Can you check your other battery? You have 2 batteries, right?
Oh yeah. Should I try connecting that one?
Yes, show me here. I mean, in the camera. This one. Yes, try it. And these wires should not be connected to each other, these 2.
Okay. Yeah, this one seems fine.
This one is fine.
Yeah.
Maybe the other one has the, shorted inside, but just be careful about that, okay? If it's short again, just take it out, okay? Okay.
Are we supposed to show you our circuits before we connect our battery?
Yes, let me check first mine and show you, then I will check one by one, okay?
Yes.
Okay, let me check my voltage first. Okay, so see, I have connected this circuit like that. Can you see that? Okay, so it's exactly like figure number 16, okay? And then I am showing you the voltage I'm getting across resistor. So it's like 11.7, right?
Yeah, that was the highest.
11.7, right? And if I just swap my leads, I'll get negative voltage. So it means that it's fine. So it's 11.7. This is a 12 volt battery together, like 3 volts and 9 volts, okay? Then I will take my batteries out and check your circuits, okay? So those who have built that, can you show me your circuits one by one?
Yeah.
Tyler, you want to show it?
Yeah, sure.
Yes. Yeah, 1 minute. So this is your resistor.
Yeah,
going
so
in the positive.
right
Yeah.
here.
Yeah, I can see that. Then you have the negative coming up, and that's going in the positive. Then your negative is going. Yes, that's good.
Okay, thank you.
Can you try connect your battery?
Yeah.
And yes, show me. Okay, you can do that. Okay, next, who can show me the circuit? Thank you, Tyler.
Thanks.
Yes, Danny. Just a minute, Oliver. I can come to you. Can you bring it near to your camera more? I can. So positive is going there. Negative is coming. Negative is going to positive. Good. Yes, that's fine. Yes, Oliver. Where is your positive? So you did connected your leg to the positive, right?
Yeah, I did.
Okay. Then your negative is coming back to the positive. Yes, that's good. Which I see is that. Yes, that's good. Thank you, Oliver. Who else is there? Who is connecting their circuit? Yes, thank you. Yes, positive is going there. Negative is coming from negative, and this is the black wire is going from negative to positive, right?
Yes.
Okay, yes, that's good. Thank you. Yes, okay. Who's this? Just a minute. Gianna, yeah. Little bit more near, yes. Yeah. Yes, okay, that's good. Thank you. Who else is there? Patrick is showing me, or yes, thank you. 1 minute. So positive is going there. 1 minute. And Matt, just a minute. Okay. So 1 minute, 1 minute. Negative is going there. And I think Patrick, Matt, just a minute. I'll see that. 1 minute. Can you turn off?
Yes, I when I did the
Matt,
resistor, I got the right values, but I don't think I was using the right.
1 minute, 1 minute. Matt, both are Matt. Both turned off. Who was showing me first? Who was showing me? Yes, you were Patrick. Sorry.
Yeah.
Yes, okay. This one. Yeah, I think you have both in the same line. No, you're something is wrong. So see, your positive is coming to your resistor leg, right? Then your
Yes.
negative is going to other resistor leg. That's fine. Then your negative should be going to positive. Yes, that's fine. Yes. Okay.
Okay.
Thank you. Matt? Yes, sorry. So it's too
Can you
much
see it?
light.
It's a little bright on my screen.
Yes. Little bit, go a little bit back. Then come. No. Yes. No. Yes, I can see. So this positive going here, negative going, this orange line is from negative to going positive. Yes. That's good. Yes. Now you guys can check. Yes. Thank you, Matt.
Okay.
Now you guys can check, connect the batteries like they are in figure 16. And who else is showing me?
I can show you mine if. Oh, never mind.
Who is that? Yes, Nicole and Will. Will, just a minute. I can see Nicole's and then I come back. Okay. So positive is going to there. Yeah. Yes, thank you, Nicole. You're good. Will? It's coming back from negative. Yes, thank you. Thank you. Okay, who else is there? Yes, Tim. Yes. Michelle, I'm coming back.
Okay.
Tim, you can, okay, Michelle, you can show.
Oh, do you want me? Okay.
Yes. Negative going to, this white wire is going to positive and the second rail?
Yeah.
Okay. Yes, you're good. Thank you. Tim, you can show me. So you are checking current now, right?
Yes, I have it set up for current.
Yes. So your voltage was fine?
I set this one up first. This was the image that showed up first, so this is just what I had set up.
But I think that this second wire is going to positive rail. That's not right. If you see in figure 15,
I think I have the positives and negatives switched, but it's consistent. Like I would just treat the negative row like the positive row. It's just backwards. I mean, I can change it if that makes a difference, though.
yeah, it will make a difference. So just change it because you can yourself forget it. Okay. Just change it. I want you to just switch it. Okay. Okay. So we are.
Dr. Khan, my battery's also just like melted out of the case.
Who is that?
This is Eugene.
Can you show? Eugene?
Yeah, it just like melted the top off almost. It's like.
So why do you think it can? Can you show me your circuit? Just leave it.
It wasn't plugged into anything. It was the batteries were just chilling inside the case.
You did not connect it to anything?
No, I didn't.
Or did you connect them together like this?
No, these weren't plugged into. They were just like sitting out. Like they weren't plugged into anything.
Oh, okay. So you just plug them in and they are just heating up?
Yeah, I didn't even realize like it was heating up. I just like saw the top just like melted off.
Oh yeah, it's happened same. Okay, can you try your battery now? Can you check your battery? Take this battery and put this thing on. And
yeah, no, this one's fine. Yeah, this one's been in. The 9-volt is okay.
Okay, that's fine. Okay, thank you. Just don't use that one. Okay?
Okay.
Okay. So anybody else?
My
Or then
batteries are unplugged and they're actually getting hot now too.
Who is this, Gianna?
No, it's
No.
Tyler.
Sorry, 1 minute, Tyler. I'll get back to you. 1 minute. I can see that first. Positive is going. 1 minute. Sorry. So this positive. So you took out the positive wire, right, Gina?
Yeah.
Okay. So this negative is going to the positive rail, and then this is going to negative. Okay. Thank you, Tyler. Yes. Thank you, Gina. You're good. Tyler, you
think-
were having the swapped positive and negative.
No, the batteries weren't they weren't plugged into the circuit board, but I think the positive and negative wires might have been touching. That's why I was getting hot, but I think it's good now.
Okay. One thing I want to tell you, I think some of you have this problem. I can just share it with you. Maybe it may help. So if you see my wires, right? I do not pluck them too much so that they are bare even if I put them in. You can see that the little conductor is showing up, because when you touch the wires very near to each other, like here, if I do that like that, so the chances are that they both touch each other. Okay, so don't make them too much bare that the chances are that they touch each other. Okay. Okay, so let me do the current measurement now. So what I found out, 50% holders are faulty, and 50% of time it's our own fault. Okay, so whenever something is heating up, try to see, is it your own fault or is it the battery heating up? If it is your own fault, how can you check that? If battery is heating up after putting your leads in the breadboard, then the chances are that it's your own fault. If you have not put it anywhere else and they are just sitting here and heating up, then the chances are that this is faulty. Okay, so always, I'm just saying that again and again, don't be too confident or too chilled out, because it can heat up anytime, because they are wires, bare wires, they can connect to each other. So be very careful about the signs and the colors as well. Okay. Okay, let me try to do the current measurement now. I will take this out and I will make the same as I have done before. I just don't change anything, but just take this one out and break the circuit and connect two wires. Okay. Maybe they should have given us more holders, because when you are trying circuits for the first time, there are more chances of getting it heat up. So I'll talk to them maybe. Okay.
Dr. Khan, I got a question.
Yes.
In my kit, I don't see a 9-volt battery, so should I go and buy one?
There is no 9-volt battery at all?
Yeah, I don't see one in my kit.
Good. Okay. Yeah. I don't know about these. So maybe they forgot it or something. Yes, I think if you can, I hate saying that, if you can, yes, you can, you may want to buy it. But I will talk to Dr. Dees and come back to you guys about these complaints, okay? That's good. Okay. Okay, so I am checking my current now. Okay. Who was that who was not having a battery? Gina?
It's me, Cindy.
Cindy? Okay. But your 3 volts are fine
Yeah.
till now? Okay. So now let me connect my batteries. Okay. Okay. So I need to turn it off, then on, and move it to the current thing, 20 amp. And let me move my camera. Okay. This is getting dark. Yes. Okay. So it's 11 point something, right? 11.7, right?
And that's in milliamps?
Yes. I moved it 20. And if I swap my leads, it should be negative. So because negative current is flowing. Okay. So let me show you that this circuit is in the current way now. Okay, so and I was connected it to the leads. Okay. So
Wait, can you show us the circuit one more time?
with the battery?
Doesn't matter with or without.
Okay, this is the circuit. It's the same as figure 15. But if you want to see wires, how they are coming out, that's how. Is it good?
Yeah, thank you.
Okay. Okay, so I'm taking these batteries off. And so 1 minute, let me figure out who did not show me. Mayor, Andrew Mayor, you are doing it with us or no right now? You are muted. Yes. Can you make it near? Yeah. Yes, so this is the voltage measurement you are doing, right?
Yeah.
No, but you are shorting it with this. So why this black wire is not going to the positive end? The other black wire. This one, yes.
That one?
This is fine, not the other one.
Which one, right here?
This one, yes. The left one. Is it going to the positive or negative?
Right there, it's in the positive.
Okay, yeah, that's fine. Yeah. Yes, that's fine. Thank you. And who did not show me? Angelo, are you doing it with us?
I'm not right now. I have the kit next to me, and I'm just making sure I have everything, but I'm not connecting anything to the breadboard.
Okay, just be careful about these battery issues, okay?
Yeah, I've already made like a mental note about it. I don't want to mess anything up.
Okay. I think all of you showed me already. Derek, did you show me?
I didn't show you, but I also am not on that part right now. So
Okay, it's fine. Sarah,
I didn't show you yet.
are you doing it right now?
Yeah, I am.
Okay, you want to show or you don't want to show?
Yeah.
Okay. Lamb, oh, you want to show? Where is that? Lamb, do you want to show or you are doing it with us?
I'm doing it. I'm just not at that part right now.
Okay, what you are doing? You are doing voltage measurement?
Yeah, I am.
Okay, Sarah, I can see. 1 minute. Negative to positive, and that's good. That's good. Thank you. Yes, Lamb, you can show the voltage part.
Okay, I'm just a little behind, so can I show it?
It's okay. It's okay.
Okay.
You just be careful about batteries, okay?
Okay.
Who else is there? Jessica, are you doing it with us?
I'm also behind, so.
No, but did you check your batteries? They're fine?
Yeah, they were fine.
Okay. So all else we are good. So we figured out that there were 2 batteries problems, I think, right? Gina was having it and Gianna was having it? Or who else was having it? Kim was having it, right?
Yeah, mine was also heating up.
Yes. So, yeah. Kim, you are also having it?
No, I had no issues with my batteries. They're all fine right now.
Okay. So, yes, I will get back to you guys who have these battery problems, okay? Okay, so we are done with this circuit part. I showed you the things, but you need to fill up the tables. Okay, so I said try 3 volt, 9 volt, and 12 volt thing, and 3 set of voltages and current, get them and put them in the values. Those who don't have 9 volts, they can just do 3 volts. Those who don't have 3 volts, they can just do with the 9 volts. It's okay, okay? Because if your both batteries are not working, then you can talk to me, okay? Because we want to see that you can measure the current and voltages both at the same time. Then we will see the calculated and measured with values. So take RM out of the circuit and measure its resistance with your multimeter. So how you can do that? So this circuit is not connected to anything and I want to measure its voltage. Oh, sorry, resistance. So I will move this to the resistance and I am doing it at 20K and just checking it. Okay, and just as a precaution, I'm taking the wires out. Okay. So I'm measuring this resistor, moving it to ohm meter, and 20K, I think. So it's showing me 0.97. Let me move it to 2K. 0.97K it was showing, right? So 1.0, 1.2, it's showing something like that. So whatever value you're getting, just write it as it is. Okay, so 0.97K I can write, and you can just compare whatever you are getting your value from using Ohm's law, okay? And do the calculated minus measured thing. Okay. Now you need to fill this thing as well. What will be the effect on the circuit if 1K resistor is replaced by 10K? So you need to fill this up, and show us. So other than that, you don't have to connect any other circuit. Okay, now I'm coming to the procedure. What is it? About resistor color code. Okay, procedure 3. So what it is, it's saying you that if you see on the resistors, there are color bars, okay? These resistors. And by looking at these color bars, you can tell that what is the value of this resistor. So how you can tell that? So if I just tell you, go towards this chart, like the figure 14, and you can see that there are first band, second band, third band, and the multiplier and tolerance. So first band has their own value, second band has their own value, and third band. So how we will do it, first band in this resistor is brown. It's very thin, but it is brown. Can you see that? Resolution is not good, but this is brown, the first band. So it's 0. No, so it's 1. Second band is black, so it's 0. You write it like that, 1, 0. And then third band is red, which is 2. So third band is actually the multiplier. So it's 1, 0 multiplied by 100. Okay, so it's 1K ohms. You will do that. And the other last band for you is golden, which makes it 5% tolerance. So it can change its value from 1K plus minus 5%. Okay, so that's why you are seeing the difference in your currents and voltages. So if I just check another resistor like this one, you can see red is 2 in the table, black is 0, and yellow is what? Yellow is 4, means 4 zeros you will have. So it's 10K. So it's like 20 into 10K. 20 into 10K makes it 2200 kilo ohms. Okay, so let me check another resistors that we have in this kit. Okay, let me just bring any resistor from here and check their band. So this resistor, this is 4.7K. Let me check the value. So in 4.7K, my first band is yellow, okay? Yellow makes it 4. My second band is purple or violet, which makes it 7. And my third band is red, which makes it 2. So 4, 7 into 100, okay? None. Right, 4, 7 into 100, which makes it 4.7K, right? And then its last band is golden, and it's plus minus 5% tolerance. Got it? Am I clear about that? Or you want to see another resistor? Maybe. Let's try 100K, okay? So in 100K, my first band is brown, makes 1. My second band is black, makes 0. My third band is yellow, makes 4. So 1, 0 into 100K. No, 10K. Right? Which makes it 100K. 1, 0 into 10K makes it 100K, right? So that's how you can find out your resistors, okay? Am I clear?
Yeah.
Okay, so if you see, let's see. So 200K, if it has 10% tolerance, so its actual value can vary from 180 to 220, which is a lot, right? So that's why you are seeing such difference in your mine values and your values. Like if my value is 2.9, your value can be 3.22 because your resistor is going towards an lower resistor value side. So it's okay. Okay. So that's how you need to do. Check out your digital multimeter, take 4 set of resistors and do the same color coded screen. You need to fill out 2.1 and 2.3 using DMM to measure your ohm meter and compare it with your resistor code values. Okay. So that's about it. I actually posted pictures so that it can maybe help for those who are not doing it right now. But I want you all to try it while doing in the lab. So if you are having any issues, I may resolve it, okay? Because if I may not be able to resolve if your batteries are heating up or something afterwards, maybe I may not respond the same day. Maybe you have to wait a day or so. So that's why I prefer that all of you, if there is no other reason, do it while we are doing. As I have not informed you guys today, so it's okay. But from next time, I want you all to do it in the lab. Okay. So still you have till 4:40. Those who have not shown me circuits, if they want to do it, they can do it. And if you are having any question, I'm here till 4:40. Okay. Okay.
Yeah.
Okay.
Okay. And this lab number 2 is due next week, but lab number 3 will be due 2 days after that. It is also due next week. Okay. Because it's just a practical and you need to fill some tables. Okay. And I actually showed some samples. That's how I want your lab reports to be, because I want things to be highlighted, what you have done, so it keeps in your mind and my mind too. So what you have covered. So that's why. So do lab reports, and yes, if you have any questions, you can talk to me.
Lab
Okay.
2 on Canvas says that it's due on the 18th, which is Friday.
No, it was for other labs. So it's not due 18 for you. It should be on 22. I can change that. Okay.
Okay.
Yeah. And the second lab should be 24.
Yeah, Lab 3 is for the 24th, but Lab 2 is set at 18th.
No. Okay. I'll change it. Okay. So I'm turning
So for
my
this
video
lab,
off. Yeah.
for this
Go
lab,
ahead.
how many circuits are there like in total that we have to make? Is it just the 3 that we did?
Yes, 3 of them.
Okay.
4 of them. One is with 3 volts, 1 resistor with 3 volts, voltage measurement. Then there is current measurement with 3 volts. Then there is voltage measurement with 12 volts. And then there is voltage measurement with 12 volts. But for you to do in the exercise, you with the same circuit, you may have to change the resistor value, like the 10K resistor, you need to put it in. Okay. And other thing you may have to do is just take the 3 volts out and just try 9 volts as you were trying 3 volts.
Okay, thank you.
Okay. Okay, I'm turning my video off, and I'm here. So if you guys have any question, you can ask me. And I'm stopping the recording as well.